today we have our guest Shivraj, software engineering leader at Cisco Meraki. If you look at real world, be it any devices like laptops or mobile phones, we don't cable anything for Wi-Fi, right? They're always over there. So when most of the consumer devices connect to Wi-Fi over there, why do we test in a conducted setup?
Your entire processing of the signal happens at the SOC level. At the first level, you are basically testing the silicon, right? The SOC, which is the wireless chipset. So in order to test that, if it is doing your modulation scheme properly, like the MCSs, your QAMs are correctly being modulated or demodulated, you need to have that conducted. When you conduct your APs, you should be rest assured that if you test it like 10 times, you'll get the same result, because there is no point of loss once you have obviously made sure that your cables are right and everything is right, your setup is golden, and you can test it maybe 20 times, 30 times, and you'll get the same throughput numbers.
So what are the advantages of doing an over there testing?
So the major advantage is that it's real. So all the results that you get, your customer would probably be getting that, right? Example, throughput, if you're doing a throughput test, your RVR test, if you do that, your near, mid and far test, if you do those kind of tests, that is a real data.
If I had to ask about the complexities involved in over there testing, so what are the complexities?
Basically invest in anechoic chamber or a shield room, so that initial investment is there. With typically when we talk about over the air setups, the repeatability is a challenge.
Hey everyone, welcome to weekly Wi-Fi Wisdom podcast series where we talk everything about Wi-Fi and the tech that surrounds it. I'm your host Sainad. I'm WLAN QA engineer at Candela Technologies, and I'm delighted that we are joined by Shivraj. He is a software engineering leader at Cisco Meraki, and in today's episode, we are going to talk about wireless testing methodologies for conducted and over-the-air test setups. Thank you so much, Shivraj, for joining. And I'm very much looking forward to listening to your insights on today's episode. Yeah. Before we dive into the topic, could you please give us, please talk a little bit about yourself?
Yeah, so basically from an academic side of things, my fascination towards wireless communication grew when I was in my third year and fourth year. Obviously through the coursework that I did for my bachelor's degree, and then for my fourth year final year project, I built a antenna. Actually, it was an over the air sort of antenna, Yagi antenna. We did some testing on it with a PCB. I mean, right now it doesn't seem that much, but at that point it was a very good learning experience, and that kind of step was the stepping stone for where I am right now. Followed by that, I did my master's specifically on wireless technologies. Then coming to my professional background, I started off as a systems engineer. That was a good learning experience for me as well. As a systems engineer, I was working very closely on the testbed solutions that we provided to our customers. So basically, I was building these over-the-air test beds for our customers there, and then I moved on to a testing role at Charter Communications, or Spectrum. It's a leading ISP in the States here. There I got, I guess, a full circle of the wireless experience, I would say, where I was involved in testing and certifying house the routers that we have in homes, not the retail ones, but basically the home routers. So that experience gave me a good understanding of wireless, right from how it is being tested, the pros and cons of some of the things that we are probably going to discuss in this podcast. And right now, I'm managing the lab for the wireless QA team at Cisco. So that gives me even more exposure towards the enterprise side of how the industry works um, from a wireless test point of view. So yeah,
Great. Thank you for sharing your journey, Shivraj. So let's get started. Let's get into the topic. So since you are discussing about conducted test setups and over the air test setups, right? So let us try to understand how they differ to each other fundamentally. So how do they differentiate to each other?
sure. Actually, I got one of the APs to have a sort of a short demo for you. So basically, this is a board of the uh, access point, and as you can see from here, these are basically your over-the-air antennas, right? So we have one, two, and three. Usually, over-the-air antennas can be passive components, can be categorized as passive components because the role of an antenna is basically to um, pick signals and transmit and receive signals, right? Whatever happens with that signal is basically being like processed by the sock, which probably is somewhere here, and it's embedded in the board, right? So in the wireless industry, I believe there are uh, these big chipset companies like Qualcomm, Broadcom, MediaTek, who basically build your SOC level chipsets. And the over the antenna, there are pros and cons and utility of the conducted environment is to basically check your um, inbuilt wireless chipset, and then your over the air basically checks your over the air antennas. In my experience, I have seen airgain build over the air antennas. So basically that is the overall difference, right? So when you compare conducted and versus over the air, so yeah.
Right. So, when talking about test setups, so what are the typical test setups for both testing conducted versus over the air setups?
Sure. When we talk about, as I said, the use cases of over the air and conducted setup is very different. When we talk about conducted setups, it's basically going to be used for, again, testing your wireless chips. So, what are you going to, how are you going to test that? You connect your antennas, the chipsets into the board using UFL connectors. And once you connect that, you can invariably have RVR tests, right? So when we talk about RVR tests, it can, in terms of the test bed, it will happen in a Ramsey sort of a chamber where there is no isolation from outside. And then you would connect directly from your chip through a UFL connector directly into maybe it could be a testing measurement tool, right? For example, Candela box, right? So you can test throughput performance, and then the major difference there is that you are using the UFL connector, and there is less path loss there. Whereas in the over the air setup, as the name suggests, it's
Right.
over the air, and you use the over the air antenna, and it's more real world. So you use that for more of mobile testing, laptop based testing, iPhones, so on and so forth, right? So your setup would be in a form of an anechoic chamber where you do not have any noise. So basically, it needs to have happen. The test bed needs to be isolated from any other RF interference. Otherwise, your testing will have a high signal to noise ratio, right? So your results will be really bad.
Right. So in conducted setups, we directly cable the access point antenna port and then the client's antenna port, right?
Correct.
So we are directly cabling the setup. But if you look at real world, be it any devices like laptops or mobile phones, we don't cable anything for Wi-Fi, right? They're always over there. So
Correct.
when most of the consumer devices connect to Wi-Fi over there, why do we test in a conducted setup?
That brings the
I mean,
point to
what is the key motivation for performing conducted tests?
exactly the key motivation there is basically, as I was kind of touching base earlier, your entire processing of the signal happens at the sock level, right? So for example, if you want to get your throughput max throughput, there are two phases when we talk about a testing cycle. um, at the first level, you are basically testing the silicon, right? The sock, which is the wireless chipset. So in order to test that, if it is doing your modulation scheme properly, like the MCSs, your QAMs are correctly being modulated or demodulated, you need to have that conducted. Over the air antennas won't give you that visibility, right? And for example, if you want to test the theoretical max throughput as well, you need to have it conducted, right? And that gives you the ability to figure out if you can actually get the phi rates, the max phi rates. So that is the fundamental reason why we test in a conducted setup, right? And for that matter, uh, you can also do EVM measurements, right? So error vector magnitude measurements. So when you connect
Right.
directly, um, then you would be able to see how much your bit error rate is. So if there is any impairments when there is signal interference, so if that is the case, then you would be using band pass filters, right? And the concept of using band pass filters becomes very, very important, and how it is uh, filtering the signals is very, very important in this case, right? So that is the key motivation of using conducted setup.
Right. Yeah. So, if I understand it right, to benchmark the access point performance in very idealistic conditions, and then also get insights on how the file layer, the access point is performing.
Exactly.
To get more detailed insights into such conditions, we go for conducted. Is that right?
Yeah, exactly.
Okay. Right. So now we got an understanding on the advantages of doing conducted setup. Now let us talk about a little bit about the challenges involved there. So what are the major challenges that come up in a conducted test setup?
Like I was showing here, um, you can see that in this board you have, this is a 4x4 board basically. So you have antennas here, here, and here, and there is one more here. So this is a 4x4 board. um some of the model, I mean, the way these I guess the vendors right now are using the frequency is that they club, maybe they bifurcate 2.4 and 5. There are various designs that vendors use these days, like OEM vendors use these days, right? So you use 2.5 and 5, you multiplex them. You use 5 low and 5 high, you multiplex them, or you multiplex 5 gigahertz and 6 gigahertz together. So the challenge there is you now need to separate out the signals and test it with your testing device, right? Um, which could be a simulated client in this case. So basically, what you would face as a challenge is that now, in order for me as a test engineer to bifurcate or to divert that signal into two separate channels, I need to probably invest on a Butler matrix or a splitter, 1 to 2 splitter or a 4 to 1 splitter, and then connect it to
Right.
a test device, right? So, your the challenges there is your cost of the test bed increases and the complexity of the test bed increases too. Now, if I'm a test bed engineer and I maybe hastily just connected all my connections, SMAs, into the test equipment, and now I see that there is a issue where instead of 4x4 rates, I only get 3x3, right? Now, if I haven't done labeling properly that, oh, this chain 1 goes here, chain 2 goes here, then I wouldn't be getting the actual theoretical max throughput, right? As an example. So basically, that is one of the complications there. The second complication is now with the cables. I have seen, I guess, first-hand experience
Right.
where there is a concept of male and female connectors, right? And SMA connectors. So in some cases, you can use a UFL male or female, and then I mean, from the testing equipment into the hardware or the board that you're using, you have to be very careful as to if you're using a male and a female. If you use a male, obviously male and male, you can figure out it won't be connecting. If you use a female to female and you use an adapter, so basically you're losing the connectivity there, right? And then your throughput
Right.
will decrease. Then you have to be very careful with your cables. If the cables are not so in the lab world, when we do connections, we use a torque wrench. You need to enable the torque. I mean, you need to ensure that the torque wrench is used in a proper way where you are not overkilling it or underdoing it. Meaning, if you are overdoing it,
Right.
it will result in breaks, and then you will have loss, signal loss as well. And if you are underdoing it, meaning if the connection is not tight enough, then you'll again have signal loss, right? So those are the basic challenges with conducted test bed. To reiterate, I guess the main one is the complexity of the test bed, and I guess in today's day and age, we want to save our company's budget, right? So investing on Butler matrix and 1 to 2 splitters is kind of gets expensive, and the fact that the test bed owner or the test engineer needs to be very careful in how the connections are made, because it is very susceptible to having throughput degradation and so forth.
Absolutely. Right. Adding on to this, I have a question on the scalability aspect. So, if you want to scale your network, right, let's say probably uh, hundreds or even thousands of clients, uh, uh, is it relatively easier to make such a setup in over there when compared to conducted setup because you have cables going,
Of course,
right?
yeah.
So is it difficult?
Of course, that is also a good point. That is a big challenge that, in fact, I have faced in my experience as well. Right? Not just having multiple clients connect to a single AP, it's also about multiple, like, you can't have a dedicated environment for one AP, right? That's also not a cost saving experience. So if you have multiple access points in a certain chamber, then essentially you have to invest again in maybe 16 cross 16 butler matrix, and that is again like $10,000 or something. So your investment again increases on a specific test bed, and the complexity again changes. And to come back to your point about the clients, some of the clients are not very friendly with regards to breaking them up and finding the antennas as well, right? If you're using a client, I mean, in terms of real world clients, right? So if you're using a mobile device,
Right.
I would be very skeptical if I'm breaking into a mobile device, or uh, maybe a laptop could be broken into, because you have these slots for Wi-Fi chips, and you can externally make modifications into that, and Nux are good examples of that. But then again, mobile devices are not very compatible that way.
Right. Absolutely. Now let us talk a bit about over the air setups. Let us come back to over the air setups. So, what uh, what metrics or parameters uh, do we get as a benefit out of doing over the air testing when compared to conducted? So, what are the advantages of doing an over the air testing?
So the major advantage is that it's real, right? It's not a pseudo test that you do here. So all the results that you get, your customer would probably be getting that, right? Example, throughput, if you're doing a throughput test, your RVR test, if you do that, your near, mid, and far test, if you do those kind of tests, that is a real data. And typically, with loss, there will be obviously a loss involved in over the air setups, right? um in a testing world, we shoot for 80% phi with losses into consideration. Again, it depends on how far or near you are to the AP. um and then the radiated power, right? The radiated power is another important aspect that over the air test beds kind of give you, right? For example, if you are testing DFS, um, so you need to understand how much power, and even for example RRM, right? All your RRM decisions is based out of the signal to noise ratio, and the signal to noise ratio basically comes from the over the air antennas that are on your access points or routers. So that is the primary reason why we use over the air testing. And for that matter as well, um, I mean, over the air, the clientele for over the air setup is again more compatible, right? Like I was saying, you can now start testing your mobile devices. Maybe there are some IoT devices that you can test. Your Bluetooths can be tested, the pendants that you get. So it opens up a whole world of like actual testing.
Right. So it is more close to realism and not just ideal
Exactly.
benchmarking of access
Exactly.
point. Right. So, and if I had to ask about the complexities involved in over there testing, so what are the complexities
So,
that
so
have
the
to?
major complexity there is, again, you have to basically invest in anechoic chamber or a shield room. So that initial investment is there. With typically when we talk about over the air setups, the repeatability is a challenge, right? When you talk about, I mean, I'll go back to the conducted side of things as well for a while. When you conduct your APs, um, you should be rest assured that if you test it like 10 times, you'll get the same result, because there is no point of loss once you have obviously made sure that your cables are right and everything is right, your setup is golden, and you can test it maybe 20 times, 30 times, and you'll get the same throughput numbers. However, in the over the air setup, your repeatability is very susceptible to where the client is positioned, and it is not very I mean realistic enough to always, like, for example, if I'm again a test engineer, and I'm swapping out APs, and I'm swapping out clients for my test in a specific test bed. So I need to ensure that the direction of my OTA antennas are really, really like close to each other, so that I get or try to replicate a repeatable environment. So that is again another challenge there, right?
Right. Yeah, and OTA can also be complex when there are multiple clients involved, right? Because the contention, there's a lot of contention, and
True, true.
yeah, and if you are talking in a very realistic lab setup, probably in a big, very big shield rooms, or uh, uh, if you are going very realistic scenarios, right? Like a test house where there is no RF isolation as such. So in that cases, profiling and assessing the results, is that even more challenging in that scenario where you are very close to realistic test setup?
Yeah, definitely. When you talk about a test house, obviously, if you are, let's say, um, testing 5 different firmware releases on 5 different APs, right? So you can't have all the APs in the single test bed uh, running your tests, right? You have to go maybe one after the other, obviously, because your other APs will be interfering your sort of DUT, the device under test, right? So that complexity is definitely there. So you can't maybe in terms of time and efficiency, you can only do one at a time. So that definitely is one of the challenges of over the air testing for sure. And some of the clients, in my experience, have also been notorious to be sticky, right? So some clients are sticky, and
Right.
then if you have multiple clients, um, uh, a- so that also degrades your performance, right? If you're doing a multi-client test or a single client test, and if you need to be aware that, oh, I have this sticky client and it is still talking to this access point that I'm testing with a different client, right? So those things have to be taken into consideration as well. Yeah.
Yes. So in your whole testing experience, so how do you choose between over there test setups versus conducted test setups? So how do you approach which one is the right one for the for your use case?
Sure. So when whenever you are in this testing phase, let's say I'm developing or bringing up a new product, which is Wi-Fi 7 capable, right? So I'll probably get until the SOC is finalized. Um, uh, uh, we need to we'll get multiple variations of the SOC, right? Meaning the Wi-Fi chip, and various firmwares are released. There is a software release or a firmware release on that SOC. So once we certify or finalize that this is the SOC, um, in that scenario, your conducted test beds or testing is primary. So you have a repeatable testing cycle, and you're just rinsing that release one after the other. And if you find bugs, you just fix them, and then patch after patch you fix that, right? Now when it comes to over the air setup, again, like we said, the real approach, if we find that there are some specific clients interoperability issues, right? There are some certain clients that are not behaving well with us, with my access point, as an example, right? So in that scenario, over the air test beds will be really, really beneficial in the sense that interoperability. So I fix that with a specific client, and then go on with the firmware releases, right? So yeah.
Yes. Um, Now, talking about the part of regulatory bodies like FCC or standard bodies like Wi-Fi Alliance, so they have lots of test cases in order to qualify a device, right? So, do they also specify certain tests have to be in conducted setup, while certain tests have to be in over there setup? So, do they also insist on these kind of test setups and on specific test metrics that they
Sure,
expect?
sure.
So
When we talk about, let's first talk about FCP, right? FCC is the regulatory body. So now so basically we need to ensure that the power of the access points and routers need to be under a certain threshold, right? Otherwise, FCC is going to ping us or slap us in our hand and say that, hey, you guys are not using your power definitions properly. And you can easily, like, to get more reachability, you can easily just bump up the power, right? So in that case, obviously, your over-the-air setup is the must, or the go-to solution, right? So you use your over-the-air test bed, and you find how much is your radiated power, and then boom, you work it out, right? It needs to be within the FCC regulatory domain. Then coming to Wi-Fi Alliance, basically they have a certification program, and in that certification, they cover most of the conducted side of things, right? And the over the air, and that is more, in my view, more of a repeatability sort of tests, right? So basically your throughput test and RVR, um, in that sense, I believe um, the Wi-Fi Alliance has um, a certain set of test equipment that they have already validated in their test houses, which they say that is golden, and then we just follow what they say is golden in their view, right? In their certification platform. So that's the major difference, I guess. Yeah.
right. So in your personal experience of testing, did any results from either conducted setup or over the air setup surprise you the most? uh, I mean, the behavior is quite opposite to what you have expected, things like that.
In my personal experience, in terms of performance being bad or good, I would say, uh, let's talk about the over the air scenario. There was an instance where um, we do a specific test where we used to test 20 megahertz bandwidth, 40 megahertz bandwidth, 80 megahertz, and then 160 megahertz bandwidth, right? And the way we used to do it is by injecting interference, so that we are forcing, basically it's co-channel interference, right? Band interference as well. So the observation that I had seen was, in so when we had um, 80 megahertz that needed to be tested, and we put interference, the router was supposed to go down to 40, but in the real environment, um, it it didn't see the interference and the signal to noise ratio. Or I think the algorithm that the vendor back then was using wasn't appropriate, and it wasn't going back down, because all these decisions are based on the SNRs, right? The algorithms. So it wasn't going down from 80 to 40 megahertz. And then they have a score based on these SNRs, right? Different vendors obviously have their different mechanisms of um, bringing the or modulating that, right? This is a radio resource management essentially. Um, and because of that, it was sticking to that specific channel, and it was not even going to another channel, right? Because once you see the interference, the access point should, because the SNR levels are beyond the threshold, and it should move to another channel, and it wasn't doing that. So that was one interesting observation that I had through over the air testing. In terms of conducted testing, I believe there was, again, going back to that scenario where I was talking about, if your connectors are not very well connected, right? If you don't use a male and a female, that exactly what happened. We were getting everything was right about the setup, but the throughput, we were not getting the max theoretical max throughput, right? So, upon further digging up with this actual setup, we found out that this test engineer was actually the adapter that. So basically, there is a UFL connector that connects from the board uh, with the help of the adapter into your test equipment, right? So that unfortunately, what was happening was there was a female to female connector in between adapter, and because of that, um, there was a female connector as well in between from the UFL. So there was a loss of
Okay.
signal, and uh, we were all curious, like, everything looks good about or great about the setup, but why aren't we getting good throughput? And then it boiled down to just a small adapter. It needed to be a female to male, and that helped resolve the problem, right? So small things like that can be critical as well. Yeah.
Yeah, it's on the
Yeah.
physical setup. Interesting. So yeah, so you touched upon this already for conducted setups. So what are the most common mistakes that you have seen generally, and how can one avoid them? So what are the best practices that you would suggest for conducted test setups and over the air test setups?
True. I mean, when you talk about conducted, it can get very complex, in the sense, if your APs nowadays have 16 cross 16 radios, right? Back in the day when we had 2 cross 2, 4 cross 4, life was pretty much easy. And we knew what chains are going where into the testing equipment. Right now, it kind of gets difficult. So, um, a general sense of how the radio chain distribution is very helpful. I think of getting a diagram of that hand is very handy, like how the 2.4 frequency is being distributed, if is it multiplexed or not multiplexed, similarly for 5 gig and 6 gig. And then as I was kind of touching base, labeling it when you connect it back to the test equipment is very important. When you have these labels, you can pinpoint, for example, you are on 2.4 gig, you're only getting 3 cross 3, whereas whereas you should be getting 4 cross 4, right? You can actually, if you have a good label on your connections, you can actually pinpoint as to which chain didn't work out, right? These are some of the experiences that I have also gone through. Labeling is a real good time saver and critical when it comes to conducted setups. And even I have seen in my experience using, you might be fascinated by this. There are different force related torque wrenches. If you use a torque wrench which like has more force, then invariably what you do is you break that adapter, right? For example, I have this connector here, that is an SMA. You can break this by using more force with a torque wrench, and once you break
Right.
that, your performance will also degrade, right? Or your results will be abnormal. So these kind of things, I believe, is very critical when you look at conducted testing.
Yeah, when it comes to over
When
there.
it comes to over there, obviously, you need to have a sense of, I guess, direction. Make sure that wherever you place the for repeatability, wherever you place your device under test, maybe it is an access point or a client, it needs to be at the same place, and it needs to be directed towards each other to get repeatability. Sometimes we use turntables as well for rate versus range versus orientation type of testing, and it becomes really really complicated if you don't know where your antenna orientation is, right? So a good rule of thumb would be that you make markings on your turntable and ensure that you place them exactly how it needs to be placed, so that you don't mess up your antenna polarization. Same goes with your clients as well. The placement of the clients are really, really, really important in that case.
Right. So I think we have covered most of the discussion points. So if you have anything to address to our audience on this topic, conducted and OTA setups, please do.
Um, I believe conducted and OTA both are very, very critical to certifying your access points or wireless routers. Um, if you consider enterprise and retail environment, it's very critical. Both have their own use cases. Um, and in terms of repeatability, we should go with conducted testing. And when it comes to real world testing, obviously, over the air testing is um, the way to go. Candela does a really good job in providing test solutions. So I have had a good experience with the test bed or test beds and the testing solutions that you guys provide. Yeah.
Yes. Thank you so much, Shivraj, for joining on Weekly Wi-Fi Wisdom and sharing your experience with all our audience. I hope the people who are following Wi-Fi and who are getting started uh, and bringing up the test setups, I think they'll find this really useful. And yeah, thank you so much for doing this.
Thank you so much for the
Yep.
opportunity, Sainath, and from the entire Candela fraternity.
Yeah. Yeah, so that's all for today's episode, everyone. So if you like the episode, please like, share, subscribe, and continue watching Weekly Wi-Fi Wisdom for more episodes on Wi-Fi. Thank you so much, and we'll catch you guys in the next one. Thank you.